Welcome to the stage, Micah Casella, an analyst at Messari, and our wonderful panel. Let's hear it for him.
Oops.
All right, fellas. Let's have you guys introduce yourselves. Let's start with Adeniyi.
Hey, folks. My name is Adeniyi Abiodun. I'm a co-founder of Mysten Labs. We're launching a blockchain called SWI sometime this year.
Awesome. Nick?
Hi, I'm Nick. I'm COO of Celestia Labs. And we're launching Celestia, which is the first modular blockchain network. So we take a radically new approach to building blockchain infrastructure where there's actually multiple protocols that handle different parts of the stack. So we do consensus and data availability and allow people to launch their own execution layers on top as rollups.
Nice. So I was actually going to have you guys, for the next question, introduce your blockchain. So Adeniyi, introduce SWI for us.
Yeah. By way of background, our team were the team working in Facebook on the research and development to launch the DM blockchain. That obviously never got to launch, but we have the pleasure of being able to work on something really innovative and creative in the space. SWI is the first blockchain built from ground up to actually scale to power applications for the next billion users. SWI has a very unique approach to scale. Namely, everything in SWI is object-oriented to a large extent. It's an object-driven data model that allows us to determine contention statically, scale, I lost the connection there, and actually scale execution of smart contracts to multiple VMs without ever needing some form of sharding and losing the domain programmability and interoperability you get. So we're very excited about that and love to talk more about it.
Nice, yeah. We're going to get into the details in a moment, but kind of before we delve into why a better base layer is possible, we should probably define kind of like what are the core components or core layers that we would break a blockchain down into, kind of like consensus, execution, et cetera. So Nick, could you start us off?
Sure. So the core insight of Celestia is that if you go back to the fundamentals of what powers blockchains, you have three major components or functions. The first one is consensus, which is how you come to agreement about the history of transactions, the order of transactions. Once you have that, then everyone's on the same page. The next piece is execution, which is basically that you process all of those transactions. You sort of like compute over them to process what the output is or what the result is. So for example, I would transfer tokens from A to B. And those two things actually don't need to be run on the same layer. So every blockchain since Bitcoin and Ethereum and including SWI is built under a monolithic approach where those two things happen at the same time. And fundamentally, that limits what you can build and what you can do. There's limits to scalability. You can kind of optimize within that, but you can't kind of break out of like a fundamental single state machine. It's also less flexible because you have to define what the execution environment is of that chain in advance. But the developer may not want to actually build in that. So even if you're building Move, which is a wonderful programming environment, there's no one programming environment to rule them all. So those are two of the main benefits of building in a modular stack.
Nice. And Adeniyi, would you like to add anything to that and kind of define how SWI works and breaks down those layers?
Yeah, I mean, so most blockchains, in our view, kind of work the same. So SWI is actually a bit different. So SWI does actually go beyond a single core. We can actually take SWI to multiple cores and take advantage of parallelization. SWI is different in the sense that we don't fundamentally believe, in fact, if I'm holding this bottle of water and I'm transferring this bottle of water to you, and he's holding his iPhone and transferring it to someone else, those are two distinct applications that have no need to have order in relation to each other. All blockchains work under the principle that we all get in line in a queue and we get off at the same time, right? Which limits the throughput. SWI, we have something called causal ordering. We have a distinction between what needs to be ordered in order to itself and then separately. So because we have quarter ordering, we can actually parallelize the heck out of applications. So for simple NFT transfers, NFT mints, sending USDC to a friend, those things do not need full order consensus. So we use something called Byzantine consistent broadcast that allows us to achieve high throughput while still enabling ordering in relation to the object itself. So I can pass you the bottle of water, he can pass his iPhone as many times as he wants, and as long as we have enough CPU, we have no throughput limitations whatsoever, which is groundbreaking. And when it comes to actual consensus, if you're doing something like a DYDX or some form of other DEX, that DEX, the ordering is only in relation to that DEX. So my throughput is not affected by some other land sale elsewhere, which is the innovation.
So there's a lot of parallel processing going on within SWI. And do you lose any of this data availability? Because that's kind of like an issue with running things in parallel, is that sometimes it'll take a lot of effort and a lot of work to be able to source all of this data from all the different, I guess, shards and whatnot.
Well,
we would call them shards.
Yeah, I mean, look, fundamentally, we think sharding is an abstraction too high a level for developers. People already struggle to do, smart contracts for escrows, right? We now expect them to understand shards. We think that's a push too far. We would rather abstract that away from a developer. If I build an AWS with Google today, SWI is a decentralized proof-of-stake blockchain. If I build an AWS or GCP today, GCP takes care of all the scale behind the scenes from a developer standpoint. They don't care, right? We believe in the blockchain space as well. If I build an app, it should take care of scale from a platform perspective. So we take full advantage of parallel execution. You can dynamically do it, but it's very expensive, and you start to lose performance as you go beyond a single CPU. We think the static element of what we do actually is the most efficient way, and we take advantage of other optimizations along the way also.
OK. And Nick, could you describe Celestia's kind of roll-up approach to processing, or I guess for its execution layer?
So what rollups are is a lot more sort of akin to sharding. What SWI does in terms of the parallel execution is actually amazing and a very important technology that should be built. But it doesn't solve several other fundamental problems. One is, again, that you're stuck with within one execution environment, right? Breaking apart the sort of like state machines so they can have their own execution environment gives the developers more flexibility. It also gives you something called sovereignty, which the Cosmos community is kind of famous for, which is that each blockchain can not only customize its stack, but also fork and kind of have control over their state. So, for example, they could undo a hack, which is what the Ethereum community did back in 2017 or 16 with the DAO fork. So I think those are two things that fundamentally, when you're within a monolithic approach, even if you do all the really brilliant things that SWI is doing, you can't really break free from that problem. One last point is that what modular blockchains enable is very, very high level of verifiability. So we actually target like a smartphone level of hardware for being able to run a full node. And you can't do that without data availability sampling and rollups. So that's another reason why we think this approach is right, is that we'll be able to be more decentralized in the long term. In SWI, you still have to run a full node, which would be a very expensive machine in order to have that level of security.
Can I touch on those points?
Yeah, go on.
Few things. So on SWI, we have a concept of a sparse node. So unlike other blockchains where you have to replicate the entire state, I can just replicate the state that matters to me. So if I'm a trading house and I have a smart contract on the blockchain, I can replicate only the state that matters to me while still securing the chain, which is actually way more decentralized than what you'd get with a traditional blockchain. It has to have the entire state on a single machine. Separately, what you get with SWI as well is the fact that you have the verification done by the virtual machine. So in traditional blockchains, if you're writing in Solidity or you're writing for Solana or writing on other blockchains, you don't natively have the idea of these constraints built in. So if in Sui, I could take an object and I can pass that in as an argument into a function and not have to do any of the verification checks that you actually have a ton of boilerplate code, which is actually a result of most of the hacks. I don't think we need a proliferation of more VMs. We need really good VMs to actually solve the security issue, because we have $100 million hacks on a regular occurrence. It's only going to get worse. We think soon you have a $1 billion hack. I think the most important thing is have a very safe execution environment that developers can build. That's how you can actually increase the adoption cycle.
OK. And on Celestia, these rollups can utilize kind of any execution environment they desire, correct?
Correct. Under the condition that they should be a rollup, which is a unique type of execution that is either fraud or validity provable. So there's still a lot of sort of innovation happening to make rollup execution more general. And that's what a lot of the Ethereum community is doing. Projects like Arbitrum or Fuel or Optimism, and a lot of the ZK rollups like Scroll or ZK Sync or Starkware. So there's still a lot of innovation that needs to happen to enable rollup execution. But fundamentally, eventually, we think it's a solvable problem, and people will be able to run general purpose execution and lots of different kinds of virtual machines. OK, nice. So let's, I think we have to address that Ethereum had a successful merge and that it's still the dominant chain for application building and development. And so, kind of the title of this panel relates to building a better base layer. So Adeniyi, what does Sui do different from Ethereum, and why should devs consider your chain over Ethereum?
So Sui is different in the sense that we've taken a really pragmatic approach to enabling developers to build that are accustomed to building in other programming languages. Sui is very Rust-like in its design. So if you're an object-oriented programmer as well, and you know Java, you know C#, you know other languages that have the concept of objects, you would feel at home in Sui very, very quickly. And you don't have to write a lot of boilerplate code that takes care of scarcity to make sure that you don't duplicate or copy an object or destroy something that shouldn't be destroyed. The VM takes care of that natively. So I think the element as well of why you would care about Sui is it's designed from grounds up to actually have stable fees. So other blockchains have this, unfortunately, have a concept of like a fixed amount of throughput, right? Like the idea that the block space is it's very expensive commodity is nonsensical. I don't build a game today, and tomorrow it's $5 to play. Next week it's $200. That's it's unsustainable from a business perspective. On Sui, the fees are actually very, very flat. And the reason why is supply and demand. If at Christmas everyone's minting NFTs, validators could throw on more capacity by throwing more machines, namely taking care of the demand and keeping the fees stable. And once that demand is gone, you shut down those machines and you have back to equilibrium again. So that's something that you natively don't have. So there's no concept of a fixed TPS for Sui, which sounds insane. But there's no concept of like capped capacity on Google, on AWS, because they've designed things to go beyond this confines of a single processor. And that's what we're very, very excited about. So
at what point does an extremely low transaction cost kind of become a security issue for the network if there's no incentive for validators and whatnot to actually participate in the consensus?
Again, so it's supply and demand, right?
Okay.
So the validators would have as much hardware as required to meet the demand. If the demand is low, you take off machines. If demand is high, you put on more machines. And the goal is to ensure that there's enough capacity to ensure that the network doesn't get clogged up with transactions. So that is definitely in there.
And how does that impact security?
So Sui is a proof-of-stake blockchain. It's a fully decentralized proof-of-stake blockchain that actually has the ability to support a lot of nodes. So as long as you have stake, you can pull the stake from a bad acting validator at any given time and put it somewhere else that's earning the right fees or keeping to the rules that you believe in. So in that sense, there's no real innovation. It's all proof-of-stake. It's two-thirds of a network vote in favor of transaction. That's still the same paradigm that you get and afford with Sui.
OK. Nick, so something I've noticed that there's kind of a I think decentralization and scalability seem to be at odds with each other sometimes. And I'm kind of curious how Celestia solves that issue.
So the key thing to understand about what does decentralization mean, it means that at the core of Web3, And the difference between Web 3 and Web 2 is that Web 3 is verifiable. So you don't have to, the fact that end users can verify everything that's happening means that you don't have to trust Google or Facebook or anyone to do what they say they will do. And so verifiability, end user verifiability, is really the crux of decentralization. Now, why is that opposed to scalability typically? It's because in a monolithic blockchain or standard blockchains, when you want to increase the throughput, the amount of transactions you can process, you necessarily have to increase the resources that the nodes use to verify those transactions. You can make optimizations like parallelization that allow you to use the same resources more efficiently, but fundamentally you always run into this problem of needing a bigger computer. And when you do that, you necessarily cut out the end users who don't have enough resources. So it becomes less verifiable by the general public. So what you need to do is build a system where you can increase the throughput without increasing the node requirements. So that's why Celestia is built in a different way, where data availability sampling allows you to increase the block size without requiring people to increase their node requirement.
Okay.
And same with rollups. Rather than having to recompute every transaction, users just verify a proof. So both of those things make it so that you can have tons and tons of transactions running through the system while not increasing the end work that the users have to do to verify it.
Now, would you be able to define data availability sampling?
Yeah, so in order for roll-up constructions like fraud and validity proofs to work, you have to ensure that the data that went into creating those state transitions is published publicly. And so that is what the data availability problem is ensuring that data was published. Typically, to do that, you'd have to download the entire block yourself to verify that it is indeed there. And so data availability sampling is a way in which you can verify that all the block data is there by only downloading a very, very small amount of it. So let's say the block is 1 gigabyte, like way in the future. You just download 1 kilobyte of data, and you can verify that all that data was indeed published. So it's like a very important and unique trick to verify data exists and was published without actually having to do a lot of work.
Okay, and so via data ability sampling, you guys are able to grow scalability while kind of, I guess, sublinearly growing the amount of requirements that, I guess, are required of the validator or of the nodes?
Yeah, exactly. The actual relationship is the square root of n, where n is the block size.
Okay,
yeah.
Nice. And so another question for you. Has the modular approach to building blockchains been proven correct? Or do like monolithic blockchains still have a meaningful role to play?
I think both will have a role to play in the future. I think that if we want to scale blockchains to this internet scale, I think we have to take a modular approach. It has not been proven out yet. There is no live data availability sampling network out yet. Celestia will hopefully be the first one sometime next year. And rollups are still kind of, I mean, they are working, but they're still very early. So there's a lot of work to be done.
Okay. Adeniyi, what's your kind of viewpoint on this multi-chain future? Would you forecast that there's going to be many chains? Are we going to have one kind of to rule them all, or is everybody going to have? Is there going to be domain-specific blockchains in the future to service various needs? Because I know you worked at Oracle previously, kind of in that architecting their the blockchain cloud infrastructure, and a lot of the enterprises tend to use Hyperledger. So how do you kind of forecast blockchain environment going forward?
You're talking about a history I want to almost delete. Imagine never existed. Before I say that, I'll probably touch on Sui is actually really modular by nature, right? It's just we don't believe, we're not religious about monolithic versus any other form. It's actually modular by nature. It's just we believe all by tradition most modular architectures take this idea that it's an account model, which we don't think scale. Like account models just will not get you the scale that you need. But back to your question on multi-chain. Look, I think multi-chain is a thing, but I don't think we're going to have tens of chains. I do think just the power of law is going to you're going to end up having like low single-digit, blockchains. I think there's going to be consolidation around where people build, and some might be app-specific, some might not, some might just remain general purpose. But I welcome it. I think it's great for the ecosystem. It's great to have that competition. It's great to have new ways for builders to build and different flavors of them as well.
Nice. And so, Nick, with multiple layers serving sort of specific functions, you guys separate consensus from execution. How do you think about decentralization, and kind of how do you measure it for a modular blockchain?
So again, I think like decentralization is about end user verifiability. So it's what is the sort of like target hardware that end user has to have in order to verify the chain. And in our case, we're targeting, in the long term, a smartphone, because that's something that everyone in the world will have or has. And so that's kind of like our threshold. Like we want everyone to be able to verify what's happening on chain. So that's how we measure it.
Okay, and how would SWE measure it?
Sorry, how would we measure decentralization?
Yeah.
Look, there are many ways to skin the cat, right? Like, it's not just about the number of nodes that you have. It's this distribution of stake, right? You want to think about geodiversity as well. Even thinking about, make sure you're not on the same data centers, right? Or the same manufacturer of hardware. There are many ends to that, and I think we think it's a multi-domain problem, not just single factor. Also, I mean, do we really believe that the idea that every consumer can load up a phone and verify themselves is a consumer problem? Not really. I think consumers, to a large extent, should care, but they don't. They just want the transactions to freaking work, right? And I think as long as you can solve that problem and do it in a way where, if someone does care, there's an element for that. Like clients, for example, it's one way of providing that functionality. But I think not at the cost of performance. I think more importantly, it's important that you can enable more developers to build and build in an open system, giving developers the tools to do that in a safe and efficient way that actually they don't have to worry about their business going under because the network is clogged up with transactions. That's actually more important for us, right? And we think, SWE is different in the sense that most blockchains, the more nodes you actually have a quadratic drop-off in the performance. With SWE, it's actually linear in terms of drop-off. And on top of that, you can add more workers to each validator to compensate for any loss in adding more validators. So we have a better scaling story in terms of number of validators than most blockchains actually do. So we have an idea of what we think the number should be in terms of number of nodes, but it's ultimately a community-driven decision. The community, via the governance mechanism, can vote to how many, the number of nodes a network actually needs to be fully decentralized.
Okay. And with roughly 2.5 minutes left, I kind of want to end on adoption. And kind of when would you expect to see meaningful public adoption of these kind of new base layers that you're building? So let's start with you.
I think the adoption starts with the apps, not the layers. I look forward to a day where people don't talk about, I'm a Solana degen, I'm a SWE degen. It's like, I just use the internet, right? Like, there isn't a Web 2 and Web 3 world. It's when you want to augment experiences by ownership that Web 3 becomes part of the use case, but with a better UX, right? So I think when the infrastructure is good enough, where people don't care about the infrastructure is when adoption really matters. I don't care that I'm using a website that's hosted on AWS or GCP. I'm just on a website, and it has a great experience. So that's our ethos. We make investments in companies that are thinking about the user experience problem because we think that's the biggest impediment. Of course, the hacks as well is the biggest impediment to adoption in the Web3 space.
Okay. And how does Celestia think about it?
I agree broadly. I think that Celestia's mission is to remove the barriers so that all the limitations of existing infrastructure that people have problems with are gone. And developers have as much freedom to build what they want. Yep. And that's going to then enable the applications that will reach the mainstream. So it is very much like a infrastructure, let's just make it so no one thinks about it, basically. Beyond that, I think it does fall kind of into application developers to come up with the killer apps.
Yep. And not having launched yet, how are you trying to jumpstart this adoption of your own, of Celestia?
So we just launched a Modular Fellows program where we are incubating a group of hand-picked builders and projects who are building some of the first roll-ups and infrastructure and tooling for the Celestia ecosystem. That's what we're focused on right now.
Awesome. Well, we're out of time, and thank you for the conversation, everybody. So
Yeah, I appreciate it.
Thanks all.
Thanks, everyone.